So under this recording, we'll be doing tutorial 3, right? That falls under the topic of superposition of sinusoidal waves. Sinusoidal waves. So let's start here with those questions that you were given. So the first question, they were given two sinusoidal waves traveling on a string of mass 3 kg, which is under the tension 50 Newton. So given the tension as 50 Newton and given the mass as 3 kg, they have their wave functions given by this equation and this equation. So here you realize that these two equations, there is one problem because in order for you to add cosine and sine, you have to use a special identity, right? So, but to make things simple, we're just going to change this one using the identity to sine. We wanted the wave function for the resultant wave. So for number one, the first one, 1.1.1, we know that we are having y1, height of t equals 1.5, the sine 0.25x. This was the first equation, minus 2,5t. Then the second equation was x of t, 1.5 cosine of 0.25x minus 2,5t. So they usually do this so that you get it wrong, right? So you'll just use this identity that says that the cosine of an angle, it will be the sine of the angle plus pi over 2. So cosine of an angle is equal to the sine of the angle, the same angle, plus pi over 2. So meaning that for y2, we'll do this. It means y2 will be equal to 1,5, the sine of, so our angle is this, right? So this is our theta. So it means we'll say 0,25x minus 2,5t and then plus pi over 2. So this one will be our second equation. So then we'll do the results, the superpositional one plus y2. So we can take out 1.5 as a common factor. And then we will have y1 0,25x minus 2,5t plus, and then we'll add the second equation, which will be what? Let's change this to, it is this one, the sine of 0,25x minus 2,5t plus pi over 2. So we're adding y2. So this one is our y1, this one is our y2. So now y1 plus y2 will be equal to, you know that if you are having that, you'll have to use this identity, right? If you are having sine A, if you are having sine of A plus sine of another angle, the identity that we'll use is this one. It will be sine of A plus B all over 2, the cosine of A minus B all over 2. So therefore, this means we'll have y1 plus y2 will be equal to 1,5. And then we're going to have the sine and no, it will be 2 times. No? If you're having sine of A plus sine of B, it will be 2 times whatsoever is inside there. So even here, it means we're going to do what? We're going to say 2 times this angle, 2 times this amplitude. No? So this 2 is coming from that identity. And then now we have sine of what? we have sine. Actually, this 2 is coming from the fact that the amplitude will always be equal. So it's not coming from that. It's from the fact that we had two of them. So it's a property that under superposition of sinusoidal waves, the amplitude is equal. Yeah, it's a property, this one, by property. So let me move, scroll down. So this is the identity, right? So here we'll have sine of the angle. It's 0, our A. This one will be our A, and this one will be our B, 25x minus 2, 5 t, and then we'll add. Okay, this is not gonna fit. Let me move it to the next page. Yeah, and then we're having plus, we're going to add this with the second angle, 0, 0.25x minus 2, 5t plus pi over 2 all over 2, and then a cosine. Now we have the cosine, so we must subtract. Now we'll take this one and subtract it with this one, 0, 0.25x minus 2, 5t minus 0, 0.25x minus 2, 5t plus pi over 2. Then 2 times 1, 5 will give us 3. y1 plus y2. So we'll have 3 into, and this will be the sine into what? Then we'll add 0, 0.25 plus 0, 0.25. We're adding right now. Yeah. So this will give us 0, 0.5x. When we add these two, we'll get 0, 0.5x. Then minus 2.5 minus 2.5 will give us minus 5t. Then plus pi over 2 all over 2. Then with cosine. So here you will just, if you are subtracting, then this all over 2. This one will cancel. Okay, let me show you this. 0, 0.25 will cancel with 0, 0.25, and this will cancel with that. So we'll be left with only negative pi over 2 on the numerator, all over 2. And this will be equal to 3 into the sine of 0.5x minus 5t plus pi over 2 over 2, the cosine, pi over 2 divided by 2. This will be negative pi over 4. Then this will be equal to 3, the sine of what? The sine, then we can divide 0.5x with the 2, then we'll get 0.25x minus 2.5t. Then this one will be plus pi over 4. Then the cosine of negative pi over 4 will give us 1 over root 2. Then we simplify this, we'll get 3 over root 2, the sine of 0.25x minus 2.5t plus pi over 4. And for those of you who might not know how to add these things, it means you'll have to go back. You'll have to go back and check this. How do you add? If you are given the y1 to be a, the sine of kx minus omega t plus phase constant, and y2 a sign, because they can ask this in the test. It means you'll have to go and check when you add these two, what do you get? You have to know the procedure, right? This will be your theta 1, this will be theta 2. So if you go and do it, you'll end up realizing that the superposition YR will give you 2a cosine of theta over 2, the sine of kx minus omega t plus phase constant plus the theta over 2. Yeah, it will be like this. This will be the result. And then let me at the new page, there was just explaining how you do the superposition, where this thing is coming from. Then the next question they were asking what? Let me see what they were asking. The next question they wanted you to explain to get the amplitude of the resultant wave. 1.12, the amplitude of the resultant wave. So at least we already have the equation. So this was 2 marks. So to get that will be easy. And then next one will be the length. Let me just write these things here. So now this one, it wants us to calculate the amplitude of our string and 2 marks. So then the next one, it will want us to do what? Get the length of our string. So now let's start with the amplitude. So the amplitude will be this part. So our YR, our amplitude AR, the resultant amplitude, will be equal to just be 2A. It will be, did we simplify? So now I'm copying this one. It will be this part. So this one, it will be our AR. And we'll have the sine of okay, sine of the angle, right? So our equation is like this one. It's a representation, AR sine of it is a representation of this. Okay. And now we know that our resultant amplitude is what is 3 over the root of 2 meters. Then you get your 2 marks. Then the length of our string. And that's the length of our string. So we can just use this equation here. So we'll say V is equal to the root of T over the mass density, it's M over L. I'm sure you already know that this one is mu mass density, right? So now you'll see it means you'll have to get the velocity of your wave. So this is the formula, or you can use the formula W over K. So it will be up to you. So I decided to use this one. So in order to get the frequency, we know that frequency is omega over 2 pi, like by the wavelength. And the wavelength is what? The wavelength, we can represent it as 2 pi over k. Then omega, the value of omega was 2,5 2 pi from here. So the value of omega is what? 2,5, right? This one. The one that I'm highlighting in green, 2,5 t, that's our omega. And then we go down, and then we know that our k will also have k at there. So our k, the value of k is 0,25. Then you'll get your velocity to be equal to 10 meters per second. And then now you'll have to calculate, let's see, you'll have to calculate T, the tension. I think it was given in the question. Let's just go back and check. Yeah, the tension of our string. So it's traveling on a string of mass 3 kg, which has a tension of 50 newtons. So we know the tension of our string is 50. So T, we already know it. So T is 50 newtons of our string. So the only thing that will be for us to substitute, and the mass was given as well, was a 3 kg. So from there, we'll say, we know that T is equal to the root of T over V is equal to the root of T over the mass density. And this one is 10, the root of 50 over the mass is 3. The length of our string is what we're looking for. Then I'll square both sides, and here we have 150 divided by 3 over n. Then I will multiply both sides by 1 over 50. And here we have 2 being equal to L over 3. Then the length will be 6 meters, right, of our string. Then you get your marks. The next question they wanted us to get what? They said the 3 values of the phase constant. Find the 3 values of the phase constant which will result in a constructive interference. The next one, the values for the phase constant which will result in a constructive interference. Here you just have to know the conditions of the phase constant under destructive interference, and also the conditions under constructive. So for the constructive interference, we know that the phase constant is given by phase constant is given by the equation of n times pi. Then our n in constructive interference will be the set of odd values, ne? 5, 7, what. Let me just say element of odd so that we don't forget. And then this means our phase constant will be, since they only want 3 values, we substitute 1 first, we substitute 3, substitute 5. Then you'll have what? 3 pi and then 5 pi. So the answer is pi, 3 pi, 5 pi. These are phase constant values in destructive interference, and then 115 constructive interference. And this one, the formula is still the same, n pi, and then n is given as 0, 2, 4, 6, etc. So this is an element of what? Of even values. This constant, our n will be the set element of what? Of even values. So the phase constant will be 0 times pi, 2 pi, 4 pi. So obviously we'll have 0, 2 pi, 4 pi. And this will be our values. Then the next question, they were going to number 1.2. They wanted us to, they said 2 waves are traveling on a 1.5 meter string. So given the length of our string, and we have got these 2 sinusoidal functions, this one and that one. So they are saying determine the amplitude of the resultant wave when x is equal to 0, 125. Okay, so it means, let me write those equations here. 1.2, 1.2.1, y1 xt. Remember here on, sinusoidal waves are dealing with 2 values now. unlike in simple or harmonic motion whereby we're dealing with only one variable, which was t. So this will be 5 sine 4 pi x minus 0.25 pi t. Then y2, so these equations, they are the same. It gave us two equations and they have the same amplitude and the same. Let me see that the first one, what was it having? Yeah, in most cases, W, the angular frequency, and the amplitude, they are usually the same. I think this is by property. Scroll down, then now we're having to 5. But the phase constant can be different. So now they are looking for the resultant amplitude. We are looking for the amplitude. So what you will do is you'll get your y1 plus y2. So 2 times 0.2575 will give us 1.5. And then here, it means you'll have to do the addition of this one separately, right? So you'll get the angle as 4 pi x. And then the part for cosine gave me 1 when I was doing it. Then this one, it will be at 1 point. So we know that we'll have y1 plus y2 as 1 comma 5, the sine of 4 pi x. Yeah, we will end up having this, right? So meaning that our resultant amplitude is 1.5 meters. So this is how I got this one. No? We know from that equation theta 1 plus theta 2 over 2 cosine theta 1 minus theta 2 over 2. We know that this will be equal to the sine of the first angle. It's what it was 4 pi x minus 0.25 pi t. So I will add the angles. So this is how I got it, and then divide by 2. This one's, oh, they didn't cancel this one, but they'll cancel there. And then multiply by what? The part for cosine, you subtract. So you subtract this and that. So it will be 4 pi x minus 0.25 pi t. Pi t, we have a t there, minus 4 pi. Let's write it the way it is. Minus 4 pi x, then this will be plus 0.25 pi t all over 2. So this will give us these two, this and this will cancel, that and that will cancel. We'll have 0, and the cosine of 0 is 1. And here we'll end up having what? What will we have here? We'll have 8 pi x, and then we'll divide by 2. Then negative 0.25 plus negative 0.25. Okay, this one will give us negative 0.5. So I was supposed to also add that negative 0, we'll get negative 0.5 when we add these two, then divide by 2. Yeah, it will be negative 0.25. So our AR will just be this part. Just be this part. So AR is 1.5 meters. Then let's move to the next question. They wanted what? 1.11, We're going to 1 point what now? 1.2.2. Let's see. And that us to calculate the number of envelopes and loops produced by the standing wave. Then now draw the resultant wave produced by the superposition of the two waves. Okay, here they want us to calculate the number of loops produced by the standing wave, 4 marks, meaning they want the number of loops. So they want to know how many times our graph will loop. So this is what you will do. The formula for calculating the number of loops. For the number of loops is given by length divided by lambda over 2. So this is just have to know that the number of loops given by this that equation lambda over 2. Then now what you will do is you will first calculate the value of lambda. So lambda, which is the wavelength of our string, it will be 2 pi over k. Then 2 pi. What's the value of k on our equation? It's 4 pi. You can check there. This is our k. So we'll have 4 pi there. You can have 1 over 2 meters. So now we can come back and say the number of loops is equal to, then we know that L is 1 over 2 divided by length were given on the equation. The length was what? Let's go and check the length. I think it was given. It was 1.5. 1.5. So we know it's 1.5. Then divide by the wavelength is 1 over 2. And then we're dividing by 2. So this will end up being 1.5, 1 over 4. Then we'll get, if you divide that by 1 over 4, you will get a 6. So our wave, our wave, our resultant wave will have 6 number of loops. So now the next question, they just wanted us to draw, and then meaning that if you are drawing the loops, remember the loop is divided into what? Into nodes and antinodes. So you just make sure that you're having, so the number of nodes will be how many? Now we are just gonna have the number of nodes. The nodes, it will be 7, and then your antinodes will be 6. Meaning, okay, the number of loops. Remember, it's what? It's the number. How many times your graph will loop, ne? So this is still the same as the number of antinodes. So when you draw the graph, it means you'll focus on the number of antinodes. So you know that, okay, my graph must go up to 6 times, right? It means you're gonna have something like, okay, 1, 2, 3, 4, 5, 6. Then the next one will just join it. Can we join this? 1, 2, 3, 4, 5, 6. Yeah, I can just do it like that. So the number of nodes will be 7. Then the number of antinodes will be 6, which is this part. So that's what they were asking on the next question. I was saying, how many nodes and antinodes that this wave pattern exhibits? So now we're going to 1.2.4. The number of nodes is just n plus 1. The number of loops plus 1. So it's 6 plus 1, which will be 7. Then the number of antinodes, this one is just equal to n, equal to 6. Now go to 1.2.5. Let's see what they were asking here. I don't remember the question. Determine the first three positions of the antinodes, and then determine the first three position for the nodes. Okay. So even here, you'll have to know the formula. For antinodes, it will be n lambda divided by 2. And the property says that your n must be a set of odd numbers. So in order to know those positions, it means now you'll first calculate a anti 1. Then you'll have your n is 1 for the first one. The wavelength was 1 over 2. 1 over 2 over 2. So the first answer you'll get here is simply 1 over 4 divided by 2 will be 1 over 4, which is just 0.25 meters. Then the anti 2 will be 3 times 1 over 2, which will be 0. No, over 4. This one we're dividing by 4. Only divide by 2 is for the nodes. And then you're supposed to have 4. 1 over 2 divided by 4. Yeah, you'll get 0.125 for this one. Made a mistake there. And it will be 1 over 8, which is 0.125 meters. And then for this one, you'll get 0.375 meters. For antinodes 3, the position 1 over 2, 4, it will be 0.625 meters. And then 1.26, you get the positions. So you'll just list them. No? Yeah, let's just list them as x1 being equal to 0.125 meters, x2 equal to 0.375 meters, x3 being 0.625 meters. Then we go to 126. For getting the number of nodes, you'll have n lambda over 2. So this is the formula. And the property says you're going to start at 0 now. N will be 0, 1, 2, 3, up to infinity. So now, for the first position, it will be N1. It will be 1 times, it will be 0 times half over 2. So the first one will be 0 meters, obviously. And then for N2, you will say 1 times half over 2. Then you'll get 0.25 meters. Then you do N3, you'll get 2 times half over 2. You'll get a 1 over 2, which is simply what 0.05 meters. And then you do 127. F will be, okay, 1.2.7, they wanted the frequency, I think. Let me check, because now determine the first frequency is not corresponding to, okay, now talking about harmonic series for the resultant wave. So you have to know the formula for frequency in harmonic series. So the one, the first three positions. So here you have to know the formula for frequency in harmonic. So the formula is just what? N multiplied by F, Fn next one. So the first thing you'll get, it means you have to get your F1. Then if you have your F1, you can get the rest. So we know that frequency is given by W over 2 pi. And from our equation, what was omega? Omega was given as 4 pi. So we know that we have got 4. Was it 4 pi? No, it was not 4 pi. Let's go up and check. Let's go up and check what was omega. Omega was 0.25. So it's 0.25 divided by 2 pi. Then you get your frequency. You'll get that the frequency is 0.125 hertz. So now this means this is our F1, right? And then since we know that we have this H1, frequency in what? In harmonic series is given by N multiplied by the first frequency. So here it's F1 H1. And then, because we always use F1 to get the next values, next. So you must know, you always use F1 to get the next values. Then we'll say for F1, it will be 1. So the values of N in harmonic series is just 1, 2, 3, first position, second, third, 4, etc. So now we'll have 1 times 0.125, which will be 0.125 hertz. Then you get F2, it will be 2 times 0.125, 0.25 hertz. Then F3, it will be 3 times 0.125, which will be 0.375 hertz. So you know that you will be having this set of frequencies. 375 hertz. And then we'll do the next one. She has they were saying consider two pipes of different length. One is open at both ends. One is open at both ends, and the other one is open only on one end. So the one that is open at both ends, it has got antinodes and antinodes. And then the one that is open, the other one is closed on one end. It has an antinode and a node. The open pipe has a length which is double that of a closed pipe with the fundamental frequency. So the open pipe, so we know that for, let me see, is the length. So the length of the open pipe, we know that is 2 times that of the length of the closed pipe. Okay, and then they say the fundamental frequency of the closed pipe is 300. So fundamental frequency of the closed pipe is given as 300 hertz. Then they want the fundamental frequency of the open pipe. Open pipe. What is it? And then they say it 4 marks. So what you will do here, the frequency of the open pipe, 1.3. You'll first calculate the length, right? Because we don't even know what's the length. You first get the length because it's an unknown. So firstly, the frequency on a closed pipe. You have to know the equations, and the frequency on an open pipe. This one is NV over 2L. This one is NV over 4L. So the frequency of this one was 300 Hz. It was given. Then NV for the length is what we're looking for actually. So we can clearly see that okay, I'm gonna have if I multiply both sides by 4L, I'll have 1.2 being equal to 1.2L being equal to NV, and then I make L subject of the formula, I have NV over 1.2 meters, right? And then now coming to this equation here, so I know that my L I can replace it with that. So I'm looking for F open pipe, then we have NV here, then 2 times NV over 1.2. And we know, what do we know? Oh, we know that here the length of this one, let me correct this part. The length for the open pipe, they told us that, let me just check the statement again. The length of the open pipe is 2 times the length of the closed pipe. So I know that here I'm gonna say 2 into 2 times the length of the closed pipe. Ne? So meaning that I have 2 times another 2 here. Then this one is the length of the closed pipe. This one is the length of the closed pipe, which is the one that I replaced there. This one is the length of the closed pipe. So F of the open pipe, fundamental frequency of that, we're going to have NV equal to 4 NV over 1.2. Then if I simplify this, I now have 1.2 over 4 NV. This will cancel, and then I will have 1.2 divided by 4 is 300 Hz. Then F for an open pipe is 300 Hz. And that's it for this tutorial.